What we practiced yesterday involved factoring x squared plus bx plus c. We have a b and a c, but the x squared always had a coefficient of 1. I don't know if you realized that, but it did. Today we're going to focus on if there is a leading coefficient other than 1. There's a number in front of that x squared. It does make your factorization a little bit harder, a little more work. So copy down your target, factor out a, b, and c for me, and then we'll get started. Pause the video, and I'll put up the answers. After you're finished, you can click play again. Pause the video now. On this first one, you want to pull out a GCF of the first two. We have 2f squared on the outside, 3f minus 4, and then we have a plus 5 on the outside, 4 minus 3f. Your factorization doesn't match right now, but I can rewrite this as plus a negative 5. Pull out a negative 5 instead, and that would give me a negative 4 plus 3f. That almost matches. This is the same as a minus 5, 3f minus 4. So now we can see that they match. These are exactly the same. Your factorization then is going to be 2f squared minus 5 times 3f minus 4. On the next one, we have a trinomial, what we were practicing yesterday. You can think about the factors of negative 24 that add to give you negative 10. We have a negative, so you know you have one of each sign. Oops. Actually, I don't like to put those in first. So we're going to have x times x. What are the factors of 24 that have a difference of 10, 12, and 2? It comes out to be a negative 10, so it's the minus 12. This one must be the plus then. Last problem, factor out your GCF first. You're always looking for a GCF. We can pull out a 7x on the outside. We would have 2x squared plus 9x minus 1, and that's as far as you can go. So here are the methods that we've learned to factor so far. Grouping, GCF, and the traditional trinomial. Today we're going to focus on factoring quadratic trinomials with a leading coefficient. There's 4 examples on these notes. They are a little more work. Your number one step is going to be to always look for a GCF first. So write that down. Always look for a GCF first. First step. When you're factoring this first trinomial, now you have a coefficient up here. Are there any factors that I can pull out of 6, 11, and 4? No. This has an x squared, this has an x, that doesn't have an x, so there's no GCF on this first one, okay? But you want to look for it first. Use what you know about factoring. For the last term, you're always going to be thinking about the factors of the last term up here. It is positive, so what do you know about these signs? They either are both positive or both negative, right? Because if two numbers multiply to give you a positive 4, they must both be positive or both be negative to come out to be a positive. If the middle term is positive, you know these are both plus. That's going to help make it a little easier here. What are the factors of 4? We could have 1 times 4 or 2 times 2. But now it's not alone, guys. Think about where that 11 comes from. This 11x comes from the inside times the outside. And what can be on the inside spot and outside spot? Those first spots multiply to give you the 6x squared. So now you're going to have to think about that too. 6x squared comes from this first spot times the second spot. What can be there? What are your options? You could have 1 times 6, and they would each have an x, or 2 times 3, and they would each have an x. So there's going to be an x still, but now we need to think about our factors. Okay, so you're still trying to figure out which one of these multiply, which pair up here multiplies to give me a 4, which both will work, but then when you multiply a set together with the inside term and the outside term, it's going to add to give you 11. It's like a puzzle, okay? So let's think this through. Let's just try some on this first one, okay? We know it has to be 1 and 4 or 2 and 2. Let's try 2 and 2 first because we won't have to move them. If I just put in a 1 and a 6, let's FOIL this out. Our first term should work because it came from the factors. Our last terms will always work because we chose the factors to start with. So you really only have to check your inside and outside term. 2 times 6x will give me a 12x. 2 times x would give me a 2x. It's going to give me 14x total. Is that what I want? No. So what you would do is you would then switch these. If I switch those, let's try that. And I know this is difficult, guys, but follow through with me. You're going to get it. It's going to click. If I switch those, if I put the 6x here and the 1x there, let's multiply now. My inside term would give me 2x. My outside term would give me 12x. Is that going to give me 11x? No. We've tried 6 and 1, and we've tried 2 and 2. Leave 2 and 2 in, but try 2 and 3. So right now we're just kind of guessing and checking. We're plugging it in. We will get a little quicker at this, but you have to start with the basics. So if I plug in a 2x and a 3x, let's check my inside and outside term. On the inside, I would have 6x. On the outside, I would have 4x. That adds together to give me 10x. Is that what I want? It is not. If I flip-flop the 3x and the 2x, I'm going to get the same thing because I always have these 2's. So both of these pairs, this one we tried with this, and this one we tried with this. Neither one of them worked. So 2 and 2 is out. We must use the 1 and 4. So let's go back in. I'm going to just erase the whole thing. Let's go back in. Start with our binomials again. 2 and 2 are out, so let's try 1 and 4. And again, we know they're both positive, so we can put the pluses in. Try your first terms and see what works. Maybe I try the 1x and 6x. Check my inside and outside term. Does that give me an 11x? It does not, so we're going to flip them. Don't flip everything, just change the x and the 6x. We're always just going to change the first one. So we'll do 6x and x. Let's find our new inside and outside terms. Well, I would have 1 times x gives me x, and 6x times 4 gives me a 24x. Altogether, that gives me 25x. Is that what I want? No. We've officially tried 1 and 6 with both pairs. It's out. It must be 2 and 3. We just have to find the right spot for them. So I'm going to do 2x and 3x. Check your inside and outside term to see if it gives you this plus 11x. 1 times 3x gives me 3x. 2x times 4 gives me 8x. And together, that gives me an 11x. We figured out our placement. Here's our factorization. Let's do a quick check. We would have the 11x as the middle term. My first term would give me 2x times 3x is a 6x squared. And our last term would give me a plus 4. So it does check out. Okay, so we want to have a good number sense here and start figuring it out without having to plug them all in. It's going to be like a little puzzle, okay? I don't guess and check on all of them. I just wanted to guess and check on that first one. So let's try example 2 together. First step, we always want to look for a GCF. Is there anything you can pull out of 3x squared, negative 16x, and positive 16? They are not. Let's look at the signs. Your last term is positive, so it must be a positive times a positive, or a negative times a negative. Well, our middle term is negative, so it must be this one. So on these binomials, we know the sign right away. We can put them in. Think about the factors of 3. Well, that's only 1 and 3, so a little less options here. And think about the factors of 16. We already know that these numbers will choose a combination, one pair, to fill in the last spot. And then these numbers will be in the first spot. Okay? I'm not going to fill them in yet, but we're going to try to think about this. Remember, our inside terms multiply and our outside terms multiply. So just look at what we see here. You have to kind of choose a number from here. So if I circle 1, 1 times 1 would then leave me to do 3 times 16. If I have 1 times 1 plus 3 times 16, and they're both negative, both of these are negative, is there any way I could get a negative 16? Well, I would have a negative 1, and then I would have a negative 48. That's definitely not going to work. Then try changing it. Instead, do 1 times 16 and 3 times 1. If you have 1 times 16 and 3 times 1, is that going to get you a 16? 1 and 16 would give me 16. 3 and 1 would give me 3, positive or negative, but they're both going to be negative here. So that would give me a negative 19. That's not going to work. Those pairs didn't work together. You're done with that one. Try the next one. So we're going to keep that 1 and 3. If I do 1 times negative 4 plus 3 times negative 4, that would give me a negative 4 plus a negative 12. There we go. That gives me a negative 16. So we figured out that it's this. And we're figuring out that we multiply a 1 times a negative 4 and a 3 times a negative 4. Now you just have to figure out the placement. Where does it go in the factorization? Okay, these numbers, the second grouping, the factors of the constant, go in the last spots. They're both negative 4, so it doesn't matter which one you put where. These numbers make up the first spot. They are the factors of 3x squared, so don't forget we're going to have the x and the x. The factors of 3 needs to be multiplied by negative 4. It actually doesn't matter where you put this one because they're both a minus 4. If I put a 3 in here, that would give me a negative 12x, and then I would put the 1 here. You could flip those. Let's do our check. We would have 1x times 3x is 3x squared. Inside is a negative 12x. Outside is a negative 4x. So that's giving me a negative 16x. And then my last is a positive 16. We got it. Awesome. Okay, I'm going to start a new video with the next 2 examples. Copy these down. If you want to try them on your own first, go for it.